Yeah, so my name's Matt, General Manager for Waterpro, Railways and Lawn Hub, three companies, I guess all as a partnership. Railways is probably more the closest one for you guys. Obviously we're based in Old Ranella, just off South Road there. So as from an irrigation supply standpoint, that's where the bulk amount of the goods come down from you guys. However, Waterpro is our distribution centre, is what's sending that stuff to Railways as well. So we all sort of work together in that regard as well, and our buying power together obviously helps ideally get irrigation goods to you. We produce irrigation training sessions like this with councils, landscapers, golf courses, I guess anyone that's happy to get a bit more of an understanding. I guess today's training is going to be, there's a bit of a brief of some basic stuff that we want to go through with you guys. I also open that up at the end. If there's certain questions about other product that I can try and answer for you, don't hesitate to ask me. Some of the stuff I hope is new stuff to you guys, and it's learning. There might be some stuff that you're obviously familiar with, depending on everyone's sort of skill sets that are around there. If at any point I get to a point that you're like I guess the whole room's across it, just let me know and I'm happy to just shift to a whole new topic. I guess predominant controllers, Scott, that you use out on site are Hunter controllers. Would that be right? I mean, there's a bit of a variety out there. You got a bit of Hydrawise as well, is that right?
Got Watermatic.
Yep.
We use a lot of Rainbird, ESPLX type.
Yep, cool.
Controllers.
Yep.
We use Hunter nodes. We've got a couple of other. We've got that one up on Adelaide Road, a Hunter in that.
Yep.
And then the e-bike belt tools, probably should know. And then we've got all sorts of other stuff.
Yep.
Little controllers around the place. Can't remember the brand names anymore. But
yeah, no, that's cool. Yeah, so as far as the Rainbird LX side of things go, obviously with that IQ capability, are you using that on a central control side of things? It's more with the Weathermatic central side of things? Yeah, okay, cool. At this stage, yeah. So yeah, and obviously that's something we can discuss further as far as if we want to collaborate on that. Yeah, so we can go on that one. So I guess all controllers, whether it be the LXs, the Hunters, I guess there's still, all of those are a dial setup controller. Most of them run a clockwise sort of scenario. I guess standard rule of thumb, and what I'll do is I'll move one of these ones to the back, just so you guys can sort of see what I'm talking about. This is a newer model X-Core, but they're much of muchness, all the same sort of stuff. The controllers are traditionally the easiest way to program most of your sort of stuff as far as your setups are always from that right hand side of a clock. That goes as far as I guess all of those controllers. It's setting up your time and date and what have you, and we work around that way. And all this side of the controller tends to be a bit more about the manual operations or the advanced settings. I guess that seasonal adjustments and stuff like that. I guess a bit more in the advanced stuff, or manual settings, whereas, yeah, as I said, this is more of your schedules and what have you on this side. And you'll see that even on the LXs as well. As you're going around, you've got all that IQ settings and stuff like that are sitting on this side. So obviously 240 volt intake supplies on these controllers, and then they give a 24 volt AC output on them. Have you guys wired up controllers before?
Some of us have.
Yep. Yeah, cool. So I guess traditionally with a controller system, obviously you've got what's called an active wire, and then you've got a common wire that's, I guess, a linking circuit on them. If you have, and I'll draw this probably for ease, but if we have 3 valves out on our field, all connected on, say, a manifold for ease, with a solenoid valve here, an isolation valve, and your controller was sitting up here. What we have is our field wire coming out from here into the valves. Inside this, obviously, if this was a setup where we had 3 solenoid valves, we would need to have effectively 4 wires available to us, because we're going to have an active wire for each station and a common wire. And you'll see that on the actual terminals of your controllers. You've obviously got the available stations accordingly, and then what would be a C or a common depending on the controller, and that's where your common wire would go. Most in Australia, and correct me if I'm wrong if it's different here for you guys, but we tend to use, obviously each wire or cable in here is actually color coded. We tend to use the black as our common wire. I know Sydney can tend to do a little bit more white, and you're a white.
Yeah.
Yep.
We should be, but
that's the standard.
what I've been doing.
Yep. And America tend to go the same way. They use white as their common. It doesn't matter. I think it's just as long as there's some consistency in, I guess, if it's in your public realm, then it's okay. We all use white, so then it's not changing in jobs. So it's always a good base point, because if you're out in the field and you're grabbing a black and you're treating that as if you assumed it, it's just good to know. So what we would do if we were putting these valves out in the ground and we were wiring them up, we would be looking at what colour we want to use, and obviously we'd have these here, and then in this one here that I've got now is a 5-core, and I'll open this up just so we can see. You can see in here we've got a red, black, yellow, white and green wire. So there's 5 cables. Your standard irrigation cables are going to come in a single core, a 3-core, a 5-core, a 7-core, a 9-core and a 13-core. And obviously the more cores you're buying, the more the cost is, obviously, because there's copper involved. So there's levels there where we find that happy medium when we're putting them out. Obviously we're putting a 3-valve system in. I wouldn't say go and buy a 3-core and a single core, because I guess it's a little bit, you've got no room for additional valves. A wire tends to break, whereas in a 5-core we're going to have 3 wires are going to be taken up for the active wire. So we'll go the other way, and we are left with our white, which is going to be our common wire. So then we've still left with 1 spare wire, and that's handy, obviously. If we went, you know what, we've just added a garden bed to here, but we've already maxed out this station and we're not getting enough pressure, or we find that, I guess, urban pressures around the area where what was once good pressure, now the pressures are gone. We want to split that station up now. We can add a valve, split it up, and it's okay because we've got a spare wire. A lot of the time when we do our irrigation designs for council reserves and ovals, we'll build in contingencies for that reason. Because I mean, what we see out on an oval now, or a park or a reserve, changes in 15 years, where there's been a new plan coming out. And if all this infrastructure's in and it's actually still okay, we can tend to we're okay just adding onto it, especially if you've got paths and, you know, we don't want to be ripping all that up just to get new wires back through. So what we would do in this instance, I would say, all right, well, I'm going to elect, if this was station 1, 2 and 3, I'm going to say, all right, well, station 1's going to be the green wire. So I would have that as my green wire, and yellow for my 2nd wire, and red for my 3rd station. And then we've said we're going to have white as our common wire. So we would have effectively a wire coming from here, here and here, and then you'd have this white one, which is your common wire, which would link to all of those valves. That's your return circuit, effectively, to create, I guess, an open circuit, a closed circuit, so your valves actually operate. Does that make sense to everyone, as far as the need to have that there? And then obviously with a spare wire, if that's at the controller, obviously we just bend that back, leave that as a spare, and then likewise at the actual valve box, wherever that is. I normally like to put a wire joiner or something on there, just to seal off the cable, because obviously we don't want water getting back inside inside that copper and then corroding it, and then that cable's now useless in 5 years' time, because obviously we all know valve boxes fill up with water. That's the reality, and it's not a great environment for electrical. So once we've done that and we've, I guess, elected what we're doing with our cables, obviously this showing as multiples is effectively just the one cable, but you've got the multiples inside that sheath. These are a direct bury cable, all your irrigation cables, meaning that you can bury them effectively straight inside a trench without the need to put them inside conduit. But the outer sheath is not UV stabilised, so once you come up out of ground, leaving it, you know, up on the side of a fence line or on the side of a building, that will degrade. you'll just see it go brittle, and you might have seen them before where you go to move them and it all cracks. It's a PVC sheath that's not built for that. So once you step out of the ground, conduit that up as well. Doesn't need to be in yellow because it's ultra low voltage, so we can treat that almost like data, which you see around the place, just that grey communication conduit as well. So
how deep is it?
legally, there's no requirement because it's only 24 volt. You don't need to be licensed electricians to work with any of this electrical. If we were to power them on, I wouldn't say this is a great training exercise, but we can power them on and I guess touch across a running circuit, and you'll feel a jolt. It's nothing strong. But I guess in that respect, it can be literally laid right below the lawn. I wouldn't advise that, obviously, from a maintenance point of view. When we do designs, we obviously give a detail of what a trench depth would look like. If it's a main line, we normally set our mains at 600 mil. That's an industry standard to put our blue line or PVC main lines down. In that trench, we would have our pipe sitting in the trench, and I normally say, well, let's left justify or on the side, and then have our cable, on the right-hand side of that. So I don't like seeing main lines with this sitting directly on top, because obviously once that soil compacts down and gets on it, this starts to tighten up, and then you try and do a repair on a mainline pipe and you've got cable here. Now a pipe repair requires a cable repair, and once you cut that, it's too tight and it tends to want to, and you're never going to get that back again. So then you need to go and get a bit of cable, do a daisy chain. So you've got joins here, joins there. It's easy just to have them apart. If you're doing smaller stuff, even residential style stuff, it's honestly, it's the same depth that you would normally do your sprinklers. So, if we're at sort of 150 to 200 mil, that's fine. The beauty is obviously having that documented ideally, so we know when we're going around and doing work on sites that we're aware of where they are. So when we're retrofitting sites, so sometimes cables have broken over time, all the valve and the hydraulics and all that are all good, but we want to put fresh cable out. We might be able to plough that cable in or put a fresh trench in. When we do that, I'll sort of still say about 300 mil at a minimum, especially on commercial sites. I'm assuming you guys at times, depending on the sites, you're obviously sending coring in, or you might have verti draining and stuff like that. We just don't want tines hitting this sort of stuff, or events. You got popular down at where the whale fin is and whatever else. You've got all that sort of stuff happening down there with star droppers and that. It's just, this is the last thing we want to be dealing with, because a small nick on this can give more grief than a complete break. At least a complete break, if we were tracing it, we would find there's just no voltage past the point if you had a locator come out. Whereas if it's nicked, it only slightly leaks out a little bit of voltage, so then there's more voltage coming out, so it's very hard to pinpoint. So the deeper the better, but there is no legal standard. And again, like I said, you don't need to be licensed to use this stuff. So when we then go to wire up the controller, we would obviously strip back our colours that we were using. And cutters.
Yeah.
One.
Well, just one? Yeah. Yeah, wire strip is much easier. Yeah. My keys, yep. Obviously, most of your controllers, especially if you're doing the LXs, you'll find are modular setups as well now. So when we're talking those controllers that are modular, a lot of the manufacturers state that they're a hot swap, which means obviously you can see in these controllers, the actual stations are actually pre-built into that chipset, like that board. You can't add to this controller, whereas other controllers have like a click-on module that you can. And the idea behind that is you don't have to buy a 48 station controller and pay crazy money. You can just start at the 12 and then just buy modules if you need to go up from that. When we do that, the manufacturers state that it's okay to hot swap, which means you can leave the controller powered on and just click your new modules in and keep going. I prefer to see that just turn the power off on the controller, not from an electrical jolt point of view. It's more, I just feel that if there's anything that's potentially trying to communicate to that, and you do it, you start seeing, I've seen problems before. As soon as you turn the controller off and on again, it's all good to go. I think if you've got it all your programs saved, just turn it off, click it in, turn it back on again, and it's a 30-second process. It's not that hard. So just keeping that in mind as well. So if we were to strip our wires,
PVC colour.
it is for like low density poly.
We've got one of those.
Low density poly, blue line PVC. Obviously, this is one of Rainbird's ones that they brought out, which you can put a 4mm tube in, as well as the up to 25mm poly. The other ones we carry will take up to 40mm PVC, so which is pretty handy, and they do have replaceable blades, which is pretty good as well. So the other ones we've got have got reversible blades as well, so if there's a blade on the back, so you can, this gets blunt and you don't have a knife sharpener on you, but you've got a screwdriver, you can flip the blade around and keep going, and then eventually either throw the blade out or as I used to do, just have a kitchen knife sharpener and just keep it going, because I would buy new blades and never put them in, because this would be, normally with maintenance this is all nice and clean, but as you know, when you're trying to do a repair and I'm throwing this into mud, then all that gets rusted out, and I'm like, that's a throwaway item effectively, so I just sharpen that up until there's nothing left. So alright, so what we would do from here is obviously, this is at the controller standpoint now. We've obviously said station 1 was going to be a green wire. That green wire would come back up, so I won't do it on this one, I might be able to actually. I won't do that. So normally what we would do is we would come back up through the bottom of your controllers. You've got a controller port, a cable port. That can normally take a 20mm conduit, and you can get what's called like a conduit flange, which tightens up on that so it seals, so you don't get ants and things like that coming into your controllers. If it's wall mounted, you know, and I guess a stud wall, it'll brick through here, but if you had like a stud wall or whatever and that was cable coming back through the behind of a wall, you've got another option here where we can knock that out and then actually bring our cable in through the back as well. Just a few different options to sort of bring that cable through, and you can leave that plug there then and obviously come in. If we were doing the wire up, obviously station 1, you would see your corresponding station that we've decided to do on the actual drawing, and we would undo that screw on station 1 just slightly, and you'll see underneath the screw there's like a little plate on there, and we want to get that wire in underneath that actual plate. So I just normally twitch this up a bit so it's not flaring. Try again. Once it's in there, obviously this would normally be wall mounted for you guys, but we just tighten that up, not over tighten, we just want to press onto that copper, and obviously alright, and then what we would then do is we would then move to our next station, which would be the yellow wire. Does that sort of make sense from there, just as far as putting the corresponding colours into the corresponding numbers that are on the controller? Every controller is going to be in a different orientation as to where you put that. Obviously the LXs run vertically down the sides, and then as you build up after 24 you go to your 25th station, which will be your top right, and you'll come down from there as well. Some of them, instead of having a screw port, they've actually got like a spring-loaded setup on the LXs, so you push that in with like a flathead screwdriver and it opens it up, push it in, release, and it will hold that screw there, or that cable there for you. Then what we would do is we would put our common, in this case the white wire, same spot, into the C or the common port as well. Now you notice on both of these controllers as well, they've actually got a port called a letter called P. Some controllers have MV as well, which is your master valve. That I guess is a master valve port or a pump start as well. So what the reason we do that and we put a different wire in there would be some of the commercial sites, and I'm sure you've probably got sites here that run master valves as well. We would then, like no different to a system like that, if we wanted to have a master valve, our master valve would actually now be effectively prior to this manifold. This main line might go over to a water meter over here, and you've got your backflow, and then we might go into a master valve. Now we might send, because we don't want to obviously daisy chain a cable over, we might send a whole new cable now back down to this one and wire up the same way. We pick a colour and we pick the common and we wire into the same common port another cable and then I guess a chosen colour into that master valve. And now the idea behind a master valve is when you turn, say, station 1 on, that controller will also bring on that master valve. And then when the system then turns off, what's happening is instead of just turning this off, it's turning this one off as well. So that main line is now depressurised. So it's got no pressure sitting underneath it. That's a handy situation for, I guess, prolonging the life of a system. If you've got a real high pressure area that's sitting, or it's, that you see sometimes when you turn valves or taps off, you get that water hammer and the hammering effect. You'd rather that just be happening back here instead of God knows what it's doing to all of your pipes over here as well. It just looks after the system a little bit better. The same cable port can be used as a pump. So instead of that being a master valve, that might be a dam and have a pump sitting there. And so what we do is we wire that back to a relay, and then that is telling that at the same time I want station 1 to turn on, I want the pump to click on, and so it's doing the exact same thing. The relay side of things becomes a bit more, you leave that to someone who's doing the electrical of a pump, and then all they give you is effectively just 2 wire paths sitting there, which is your relay input, and you just wire up that side of it, obviously, because the other side of that relay would be 240 volts, so we don't want to be touching that side of things. So does that make sense as to why we put master valves into systems as well? Residential sites or really small sites, sometimes I'll sort of, especially if all these valves were right here, I'd start to query whether a master valve's always required, because I sort of think, okay, well, what are we protecting? Are we just trying to protect the manifold from blowing out? Is that really worth us putting a whole nother valve in and then that's another maintenance point to look after? Sometimes the standard is, we just master valve every job we do, and then of course that's how we would design accordingly. So yeah, obviously now we're at a point where effectively the controller, we've got our common coming in, stations 1, 2 and 3 have been wired up, and we've got our black, which is a spare. Some people tend to wire that into a 4 and leave that just there as it's connected. I prefer not to, purely again from a site, from maintenance point of view. You guys might leave council and someone else comes back into this council and sees number 4 wired up. Now you knew that meant nothing, but then they're turning on this valve 4 that's actually going out to absolutely nothing on the field, and they go, report back, valve 4's not working, but there is no valve 4. So it's just leave it out, and some people have gone to the effort of just putting little like tags, like the printing labels that you can get, just having spare like sitting on that and just sitting in there. It's just handy to know because I've seen it in audits before. I've gone to try and find to the point someone's wired up 40 odd stations and there's 26 actually being, and I was like, I'm thinking I'm only getting half this site turning on. And no. Yep. Then from there, that's effectively that from a wiring side of things, that controller's been wired up. It's ready to go. Then on the other side of things, I'll move to building a manifold. Do you tend to do more when I say a manifold, something like that? Or do you do a PVC individual valve?
Depends
varies.
25 mil stuff, I prefer to do it that way.
This way, yep.
I can't remember what we did. Do you remember what we did when we built our seagate? Did we use that or did we use PVC?
PVC, no, I thought it was grey stuff, wasn't
But
Yeah.
it tends to be like if I'm putting in 40 mil, 50 mil valves or something, that's probably going to be PVC.
Individual valves and that, yeah, and that's the commercial standard for that as well. So, all right, so
I do like those though, because it means you can get the valve out easy.
yeah, absolutely, and they do make, just so you do know, they make these in a 40 mil fitting
Rightio.
as well, which is handy sometimes because people go, that's great from a barrel union point of view. If I ever have to deal with it, I don't have to cut PVC out and deal with it again. So,
Some holes and shit.
yeah, exactly.
Valve box with those, so.
Yeah, that's right. These give, I guess, across the industry, these products get mixed results. People say these are the biggest cause of a leak, and I'll never use them ever again. I've installed, before I was working with Waterpro, I've installed hundreds of these, and they don't leak. Obviously, you have failure in some of them, but there's processes behind how to use stuff, and it's once you're taught properly, it doesn't leak. So in this situation, and I've used this one for now, obviously because we're doing a 3-valve demonstration, this part is effectively a 3-port manifold. These are made from Tablet, which we distribute, or Spears make one as well. They're much for muchness, they're just different brands. They look identical to each other. This is a 3-station port, so it's actually been pre-molded. All your 3 valves are perfectly spaced apart. And then all I've done here is they make an end cap as well. And inside the end cap, you might see there's like a purple O-ring sitting in there. That means there's no thread tape required at all on this. We do that up hand tight. So that's tight enough now, and that'll handle 1000 kPa. So that's pretty straightforward sort of stuff. You'll see in the ends of these as well, there's an O-ring sitting on that flat face there as well. That's where your nipples, for example, this nipple, you see it's also got a flat face, so when we do that up, that's seating against that rubber O-ring, and then we tighten this collar up, which pulls that onto it. While we're talking about all this, when we see a leak for a manifold fitting, the reason I see the leaks is that manifold, that's got an O-ring sitting on there, okay? On the nipple, you can see I've also got purple O-rings on either side of the manifold as well. So I'll take that's an O-ring that's sitting on there as well. What happens is when that is seated there and we pull that up, we want this to be the O-ring that's seating, because that's where the water would be leaking from, is between these two connections here, because that's where the water is. When we leave that O-ring on and we do this collar up, it's preventing that collar from getting pulled tight enough. And people think that this O-ring is actually seated against here, but that's not, because water is actually seated in a different area. So it's just a common thing. If you've got one of these flat O-rings, I pull the O-ring off the nipple, and then I'll use that in that spot there. So then we would do that up, and again hand tight, and then that's actually tightened now, and effectively I'll just throw that into my toolbox as a spare O-ring if anything happens to fail. When we go to a ball valve, obviously I've got that O-ring there and it's on here as well. I'll be able to know, okay, well I want the O-ring on this side because I don't have an O-ring in my ball valve. So I would leave that O-ring on, providing I can get that all the way up. As you guys might have seen with some plastic to brass threads, it gets tight halfway through. And then at that point I'm like, well that O-ring's not even touched that face. So then thread tape would be required. So one thing you do not need is when you go from this into there, because we have an O-ring, no thread tape on those fittings, because all you're doing is flaring that collar up, and it's actually going to cause that to fail. So all these fittings do not require thread tape at all, which is handy to have when you're out on site. And as even with the 40mm stuff, it's the same principle. And a 40mm valve, even if you went to a 50mm valve, most of the time coming up in 40mm is sufficient for that small amount anyway, because you're not going to have a lot of pressure loss. And then we can just go back up to bigger valves if we had to as well. So the 40mm stuff's really handy. We've done it with some horse arenas as well. because they get a lot of foot traffic and movement, the pipes tend to want to crack, or they'll get shift and then they'll snap, and then they're like, we don't want to be cutting this out. So that valve might move, and so then they can come back and just undo the collar, dig around, move it back, tighten it back up again, and they're okay. And that might only happen once every 2 years, but as opposed to digging it all out and
I guess
gluing.
the other things are 40 mil or 50 mil are probably more likely, it's not as big a deal, it's probably more likely putting one valve in the box.
That's right. Yeah.
25 mil, you might be trying to cram three
Yep.
valves in the box.
Yeah.
And you can't spin the valves around anyway.
No, without taking the whole bonnet off and doing all that sort of stuff. That's right.
So they're obviously a lot more
Yep.
useful.
Yep. Obviously, this is the manifold that we're seeing sitting like that. Oh, sorry. Like that. And this is the isolation valve that we're putting on as well. Now, as I said, I've got an O-ring sitting on this side, but I didn't have it on there. I took it off on that side because we're going into there. So for this here, we'd be able to thread that up, tighten up onto the O-ring, and we're good to go. Now, obviously, we want that to be pretty tight, but we would be fine. And the beauty of all of this is we can still shift that on that collar, so I can get that sitting nice without having to put thread tape in and muck around with it as well. So that's effectively your isolation valve. We've got out to your main line from there, or back to the water meter, or your backflows and what have you from that side of things. Then you come to your solenoid valves. Same scenario that we were talking about with your with the O-rings on these, is we take one of these O-rings off. Reason being, again, is that in these, because of the barrel union collar, it's got the purple O-ring sitting on them. So we don't need that to be a problem here. However, on the solenoid valve, there's no O-rings on there, so we want to put that side of things with the O-ring into the valve, being mindful that you're putting that into the right flow direction, which most of the valves will have an arrow on you for you, but if they don't, traditionally the coil is downstream, so that's your outlet normally. Then we would just simply, and this is where the beauty of these come in, if this was in the ground and then you were doing this, if there was already valves here on a PVC system, trying to spin this in, you're hitting your next valve, and you just can't do that. So then it's real hard. You've got to be methodical about how you build your PVC manifold, whereas here it doesn't really matter. You can just hold this valve upright and then do that collar up, and your valve hasn't actually needed to spin at all. And now our valve's on our manifold, ready to go. And obviously we can go out to PVC, poly pipe, drippers, whatever we need to from there. Does that make sense so far, as far as all that? Is there any questions regarding the manifold side of things? Now, the next side of things is, and I'll just quickly put another valve on, just so we're across that. The other side of it as well, is this is when I was installing, if I had a plan and I knew what I was about to do, and go out on site and I knew how it was all going to be orientated, this is all getting done at your ute, the back of your utes, or out here, and then you can take this out to site and literally just drop that in as you need to, or have that ball valve just sitting on site like a plumber's giving you an isolation point or what have you, and then this manifold just comes back out on site. You just do this collar up and it just literally slides straight in. The beauty, and as Scott was saying, is if this valve fails, if that was a PVC built system, to take this off, I go, I want to turn my valve, I can't go any further. And so what people tend to have to do is take the coil off, take the bonnet off, so you've only got the top of this bit, and that allows you to spin it, and then you've got to still got to dig around all that, and that could be gravel or a concrete paver or whatever else happening, whereas we don't need to. We just undo that collar, or cut the poly pipe this side, lift the whole valve out, deal with what we need to deal with, and put it straight back in again, and all these valves haven't been disturbed at all, which is quite handy. Obviously turning water off before we do that, because as soon as you undo that, water's going to come out. So now we've got effectively in this situation, 2 stations ready to go. and our wire would have been run out into the field coming from the controller and is sitting in the valve box with a loop ready to go. When we do, this is more from an installation standpoint, but it's handy if you're doing a rewire in a valve box that may have given you grief before, or cables just get shorter and shorter. What we tend to do, and I do this a lot in the golf course situations, is irrelevant of height, but because it's close enough anyway, but I sort of say, if you're standing there, I like to see from the valve box, bring your cable up to your hip, and that's your, like you pull that cable through in a trench and have that up to your hip height. That way then you pull that back in the valve box, you've actually got, you know, this much you can kind of work with, not sitting here with this, you know, you do a wire join wrong, now you're shorter, and it's just getting, in 5 years time, you're like, I've got no cable left, and you have to start digging back to try and find something spare. So what we'd have this sitting there, nice and clean, ready to go. If you've got a plan as well, and even central control, you can put notes in your systems and stuff now too. It's handy to have these colours noted somewhere, not just a once off, because obviously if you were, you know, undoing them and refixing them and all that sort of stuff, obviously you think, oh shit, what was that colour? You don't have to go back to the out to the valve box and retrace the cable back to the first solenoid valve. You can just have this numbered inside the box. They've got Velcro here and in the bags, and a lot of the controllers all have that ability. You can just put notes inside, even your cabinets, just putting pieces of paper up just to give people enough information. Because as I said, 20 years from now, and when I used to do audits, that was the biggest problem, that like trying to find what cable went to where. It was spent longer than anything else. So right. So we've got our station valves, same corresponding to what we've already done in the controller, and now these are sitting out on the field ready to go as well. What we tend to see, and the reason I've stripped these back, is there's a couple of options to show you how people wire these up. Right, so now, where are we going to go? Let's treat this one, actually I've done that the wrong way, because that is there. So that's obviously your station manifold, like I said, sitting there. We've got stations 1, 2 and 3 sitting there. So that would be my green coloured station. AC controllers use an AC coil. AC doesn't have any polarity effect to it, so it means, as we may have used Hunter nodes before, the battery controllers, where they're a black and a red cable. As you see on your multimeters, they can run polarity, so they have a positive and a negative. AC doesn't have a positive and a negative. It doesn't matter which way we go. So hence why you see on these coils, they're both red. Rainbird, both black and white cables, depending on the valves. A lot of the time they're all the same colour. And that's the indicator. It doesn't actually matter which way we go here. And you can cross that over with each valve. It doesn't have to follow sort of suit when you're actually wiring them up as well. So when we've got our cable coming into our valve box, and we've said, yep, valve 1's going to be green, we can pick one of those 2 wires coming off of that station. Now, what I tend to see, and the biggest problem with faults out in the field from irrigation joins, people strip like I've just done that, and then they've got, and Hunter don't, or all valves don't help themselves in this regard, because they do this because you can solder. But you've got that pre-stripped piece there that we take off, and people tend to grab these 2 and do a twitch, and in the worst situation, that's all, and that gets put in the valve box, and that will last, depending on the season, probably 3 to 6 months before you get valve failure or communication failure, because there's obviously, that's copper. You've seen the colour of copper fittings or copper pipe where it gets that green oxidisation. That's what's happening. And then when this heats up, because it's got voltage going into it, it acts like a pump in that sheath. So water is actually getting pumped back up that. So we've seen what starts here can be 50 metres down is completely corroded, and so that cable's done. Putting that in like insulation tape, a little bit better, still not great. The next side of it is people solder that joint and then put a heat shrink cap on. That's completely fine as well. As far as a solid connection, soldering that and putting a heat shrink on is as good as any other sort of connection. However, there's irrigation joiners out there as well. So what I tend to do is use the 3M 314 wire joiner. I'm going to show you a few of these. Have you guys used the wire joiners before? Yep. Cool. So pretty straightforward. You'll notice on the wire joiners, they've got 3 inserts. And all of them will come with 3, like all your wire joiners, they come in all different sizes. They can do little 1/2 mil size. These will go up to 1 mil cable. And then you can do a black, instead of the blue, they do a black top one, which will do 1.5 mil cable as well, depending on how far we need to go as to what size cable we're using. The reason they have the 3 inlets, so these units are filled with a gel inside them that stops moisture getting into that joint. So as we're talking about with that corrosion, it stops that moisture getting in. So what we do, and the reason there's 3 is because, as we were talking about, if you've got, these are your stations. If your station, you've got your wire joint, your wire coming in and coming from your valve. So this is your solenoid valve coil with the 2 wires coming off. This is your green wire. And we're doing a wire join here. That's just 2 wires, green in and grabbing one of those stations out of the valve. But that common wire is what was linking all the valves up. And that's why we have 3 ports in the wire joiners. So then our next station is sitting here, which is the yellow. So that's sitting there. Now our white, our green's going back to our controller and our white's coming down. What we're wanting to do here is that white is connecting into the wire joiner, but we're also wanting, and I'll jump that over, but that white is also then connecting back into this one, if that makes sense. We've got a wire join happening here, and then we're going to connect our white wire into our white wire and then continue to our 3rd station, which was our red. So we've then got our white wire going back to our controller. Now in this situation, obviously with 3 valves, you can see here is the white, and that is the red, and that's the yellow. So does that make sense? Is that clear enough? Obviously I've got one colour texture on me, but that's why we have that 3, because we need to be able to link multiples in that. And when we need to do that, obviously we need to have a little bit of a daisy chain, because obviously that piece between this wire and that wire is only, in this situation, is only a little bit of cable. If your valves, as Scott was saying, you've got valves that might be in their own individual boxes, it's not as big a deal, because all we do with our common is we bring the common back in, and where we cut the cable, you've effectively got common twice. So you would cut that cable and the 2 whites come back up, and then you grab your station. So you've still got that then continuing down the, might be 20 metres away down to the next one. However, in a valve box, you don't want to have all 5 cables cut. We only want to be dealing with that one. So I normally just grab some off-cut and grab a link of that, and we daisy chain accordingly. So what I like to do, and a lot of people don't, I've seen this not get done, is people get the wire joiner, or sorry, their wire into their wire joiner, and this has been stripped, and they'll put that in through the gel and so the end. Now that's, you can see there, I've actually got that red far enough in that it's inside the protection. Only just though, probably still not quite enough. And what we see is people have stripped that back this far and then gone and put a wire joint on there. But I'm like, but your copper's still exposed back here still, so it's still going to corrode. So your joins happened, yes, but it's going to corrode still. So what I tend to say to people is, when we're doing a wire join, I get my valves and I cut that cable clean like that. And my station wire, I do the same thing. As clean as I can with a pair of pipe cutters. And the idea behind these wire joiners is they actually have a metal bridge, which you'll see inside underneath the blue. There's like a metal bar in there, and that's what's causing that electrical bridge. That cuts through the plastic sheath of the actual cable. And so then it cuts through that and then connects into the actual metal or the copper of the actual cable there for you. So what we want to do when we're doing a wire join is we grab that. This is going to be our active wire, so it's our coloured wire that we're using for the valve. We're getting the openings of this, and we're putting our active wire from the valve in and our active wire from the controller in. And we put that all the way in. It's a bit hard to tell, but you can see there's actually colour coming all the way to the top. We want to get that wire all the way to the top of the actual, past the actual bridging point there as well. Because obviously if it's not enough, it's just going to fall out as well. Once we've got that in and we're holding that there, and I'll come around and do a couple of joins as well with you guys, but we've got that there. We basically, with a pair of multi-grips or a pair of pliers, we want to come through on the top of that, and we just press tight. That will come through. You'll see a bit of the gel come out, and that connection's done. And see, I haven't actually had to strip any of that wire. I've just done clean cuts on these, and that's actually gone through and connected into that for me. When we do the same thing for our white, and what I'm going to do here to make my daisy chain, I'm going to cut a bit of this cable to do it. So now, because we've obviously got our green wire's been done, and then we're wanting to link our common up to be able to do all of our valves. So we grab our white, we put that in the same thing. We grab our daisy chain. Sorry, no we don't. We grab our common wire, the other wire that was sitting there for that valve, and put that into the middle slot. It doesn't really matter, but you can put that into the middle slot. And then we've got our third slot is our daisy chain. Now that's going to be my common link to be able to then let me go to my next valve. So we do that. I then grab my multi-grips. And that join's done. Now effectively that, other than needing to still connect all my other valves up, because that's actually been linked now back to my main field wire, station 1 would turn on now if I wanted to turn this on, which, let's test that I've done a right connection. You heard that click, obviously running now. That's buzzing. Yep, so that connection's all good. That's a waterproof connection. We're completely fine with all of that. That can stay in the ground for 25 years and hopefully never be a problem. A lot of the time I tend to, because that can tend to look like a bit of an improvised homemade explosive device sitting in a valve box with wires and colours going everywhere, I tend to try and keep a little bit of this sort of stuff a bit neater. So we tend to, when I do installs, I'll get all of that and I'll put a cable tie around that just to keep it neat, and then I'll do the next valve, and then I'll kind of bunch all them together and do another cable tie. So you've sort of got that all tucked neatly away in a valve box, and then if you ever needed to work on it, you can just pull that up and actually see what's going on. If you need to service it, you can cut your cable tie, but you don't have a field of wires sitting there with redbacks running around and all that sort of stuff. So all right, so as you can see, we've got this is our valve 1, we've already wired up, that's all done. Yep. Now we saw according to the diagram, valve station 2 is going to be our yellow wire. All right, so as I said, we don't want to see a stripped wire, so I normally cut that one there. All right, now, you can do this side of it, but we've got this is our station 2 wire, and as I said, with AC coils, it doesn't matter which way we go. So what we want to do is we want to cut one of those off, which I've already done for you. You grab a wire joiner, and you'll see, as you put that in, if you look in the back of that, see how you can push it and make sure that you're getting to the end there. And it's imperative that you get that to the end, and you can see what we mean by that, getting to all the way to the end there, because it's obviously, you may think you're there, but it's not. It's caught the metal or something like that. So that's why they've kept that clear on the back, so you can actually see that you've actually got all the way in.
It's also important when you clamp that down that it's all the way clamped.
Yeah, because you can easily grab it on a multi. It's a good point as well, because you can easily grab a multi grip or a plier, and then you kind of grab one corner of it, and so the thing's sitting like that. And so all you've really done is bridge the right hand side. You haven't actually really gone down through it all.
When you test your system and that solenoid, you may have issues and you're like, shit, make that be the first thing you possibly check, because
Wire joins are decoders or multi-station. It's always wire splice is your main issues.
may not
So
have worked. That might be the one in
Yep.
a packet of 50 that just didn't work.
Yep.
Pop those together.
Yep, that's it. Might have. That's it. You'll sort of see you get a bit of gel come out at the top, which means you've sort of squeezed that pretty well, and you're happy with that. All right. Now we know we did the next part of it is we had to do our common. Now we've linked our green common, so that's all back. That's going back to the controller, which is this cable here. But we've left ourselves that daisy chain to be able to link our other station up. So we're going to do the same thing here with the other wire. So I'd be cutting that one off. That's it. Now for this training purposes, I'm happy just to do the 2 stations. We won't normally what you would do in this situation, and actually I will do this part for you. We'll go. Now the reason I've done that is because I want to be able to link this valve up still. Okay, so we would grab that one there, and you can do this one if you want, but we would grab that one, and then
Essentially, you did one doing the white to each valve and the coloured.
Yeah.
Yeah.
So these ones technically should be the white common ones.
you could use them as a piece of white. Yeah, so what I would tend to do, if I had this cable and I had some spare and I was in a valve box like that, I'd cut 40 centimetres or whatever off, and then just open it all up and just grab the white out, and then just do white, because you can visually see this white looping, and it's very easy then if you go into a valve box, you can kind of go, okay, I can see that white's my common because it's linked to everywhere. Whereas other sites might have the black, or I know Tasmania do yellow, so I don't know, it would have purely been just from someone working there that's... Yeah, that's right. So so you can link those ones up now, that's fine. And I prefer to use these 314s or the 316 wire joiners. I don't know what wire joiners you guys... Yeah. These are the best joiners. I use them for residential and commercial. They're just a simple joiner.
Unless we have to use the
DBs.
Yeah.
Yeah.
If they're spec'd into the job, yeah.
You can see, even you're holding this now, but if you're on your knees in the ground, how easy it could be sometimes for that cable, just one of those 3 cables just to have slipped out, and you're like, oh, I've clamped it and I've missed one. Obviously, if that's the case, these are a one-use situation. If that's the case, cut that off, throw it away, start again.
Can you reuse it?
No. I've seen people have a good crack at it, like opening them up with. It's normally 3 o'clock on a Friday afternoon, and you go to your ute and you've gone, I have none left, and this needs to turn on tonight. So I'll pry that open and have another crack at it. So yeah. So and the only reason I say, or the 3M state that they're not, is obviously because they don't have that release. So when you're doing that, you're prying that open. It's giving it an opportunity to get water in. And obviously you've then cut cable out, which has had gel on it, and then you're throwing that out, so there's less gel in that connection now. So it's just, the whole fitting's compromised. But yeah, it happens. Perfect scenario, sitting on a table doing a wire join, but muddy day and it's, 40 knots in your face, you just want to go home. Like, yeah, but people do what they need to do to get out of there, so understand.
We don't ever do it and then go back and repair it later.
Oh, I trust you, mate, that's fine. Yeah. Does that make sense? Is that all good for that side of things? Yep, cool. What I might just, while I've got this here, I might just, I'll cut these fittings off, and I'll just do a quick diagnostic on some valves for you guys as well while we're here, if that's cool. So,
Is there any other questions while Matt's doing that? Like anything else that you find is a pain in the arse in the field, or?
Did you follow that as well, Jamie? What's going on there with the wiring up? Yeah. It is pretty straightforward. It's just doing it. Let you leave the follow what's going on there. Yeah.
I think if you've never been exposed to it before, it's just new. But yeah, I was going to say, like, once you get it, yeah, it's fine. And again, it's one of those. If you don't do it all the time, you might forget it. But it's very simple as far as knowing that with an AC system, you're always going to have one colour to one valve, and then there's a common. Doesn't matter what controller is out there, it's always the same. No matter where you are in the world, that's the same process. The only time it changes is decoder systems. Have you got decoder systems out here?
Yeah, a couple of decoder systems, yes.
Yep, so that's a different day. We'll do that. But decoders, I believe, are moving forward now. More and more commercial systems will move away from this side of things and go to decoder. And then Rainbird's new IVM system, which effectively is the coil is the decoder. So their new IVM is actually that solenoid valve, the solenoid coil, has a computer chipset in it. So at any point, yeah, it's got an address in it. So we're actually telling the controller, like, it might have 1, 2, 3, 4, 5 on the side. And we say, well, station 1 is address 1, 2, 3, 4, 5, like a mobile number.
Oh, okay.
If that makes sense. And that's how decoder sort of works. And then we then go to station 2, and it might be 1, 2, 3, 4, 6, depending on how these come out.
You have to take that coil to the control what you do with the decoder and program.
Yeah, so the Hunter decoder, if you've got Hunter decoder now, you would have had to put it into a programming port and tell it that it's Hunter's the only ones that do that.
Webmatic is the same thing.
Oh, do they? Okay, cool.
The two decoder systems that have got you.
Yep.
Take the decoder back to the controller.
Yep.
Plug it into a decoder port.
Yeah, okay.
Program what.
Yeah. You can do it on the field if you've got a handheld programming device for $1,500 or whatever.
Yeah, it sounds like the investment.
Yeah, it should. Yeah. So whereas Rainbird tend to have, so Rainbird's valves, decoders have an address on them.
That makes a lot, that makes sense.
Yep. And then their new IVM is no decoder. So it's like decoder, but they've taken, obviously, and the reason being was, and a big part of it, as you saw, we're doing all these wire joins, there's things that can go wrong here. So when you do a decoder, you've come from your field, which is a 2-wire only, it's only 2 wires. It talks to the decoder, you've got a wire from the 2-wire into the decoder, which is 2 joins, and then out of that decoder into your solenoid valve, which is another 2 joins. There's 4 potential failures there, whereas where the IVM, they've halved that because they've gone 2-wire straight into that. That talks to it. And then you can have diagnostics now with the new IVM that if it actually, you could have 70 valves out on a field and it will tell you valve 59 is red. And it will know that valve 59 is red, and then also, but valve 60, 61 following is all red as well. Now that for me tells me if everything 58 and forward is good, cool. I'm going to go out to between valve 58 and 59. Someone's done some root pruning or something like that and gone straight through cable. That's an easy find. And 90% of the time it is that simple. And it's the same technology they use on golf courses now, instead of having to try and find where there's voltage leaks and all this sort of stuff. So it's really, really handy. That's where we're seeing a lot more councils are starting to go into the IVM side of things now.
The Hunter will tell me that. The Hunter,
Correct.
Well, not exactly the same, but I mean the Hunter will tell me that there's a fault at 58.
Yep.
So you know that's your starting point. So they're going to be at 57. The wire join
Yep.
at 57's
Yep.
failed. Wire join at 58's failed. Because then in 59, 60, 69
Correct.
will not work.
Yeah.
That's
Yeah.
where the fault's going to be. Otherwise, it's going to be if it's just one station that's coming up with a fault.
Yep.
Then with the Hunters, because they've got trouble with decoders,
Yep.
I know that probably my first port of call is the decoder at 58.
Yep.
Yeah, shit, and they always fail. So
Yep. That's right. So you're spot on as far as you do get feedback. Where the IVM gives you a bit more is you get a higher range of diagnostics in there, so you can actually tell and you can ping all your addresses and you can set that up from a central control standpoint. At the end of a Friday, just go, I want to know how every coil's out there in the field, and then it'll give you a report of anything that's red, and you sort of go, oh, okay, well I know, for sure valve 50 that's coming up red, that's not going to come on this weekend, but I'm okay with that because I can deal with that on Monday, but it's 40 degrees. We actually really need to go down and figure out why that is. So it's really handy. You can do that literally from your computer or on your phone and ping every coil out in your whole site and tell you what's going on. So
obviously, like the other CPU ones that you can set up and send you a message anyway. So Saturday,
yep,
it doesn't come on. So Sunday morning when I wake up, it says on my email.
Yep, that's right. So we can set up as many alarms and alerts that we want to see, so we can have it where, especially if we put flow sensors at the start of the systems, they do what's called seek and self, which is search and eliminate low flow or excessive flow situations, and that's a case of us being able to say, well, a station's supposed to be doing 50 litres a minute, and all of a sudden that station's turned on, it's doing 150 litres a minute. It's going to shut that station off because it's reached a threshold point that we said any more than 30% over, I want it to turn off. Turns the station off, moves to the next station, and then if it's all good, then it will just continue on with the rest of the cycles, but it's shut that high flow station, and then Scott would get an email in the morning saying station 12 high flow recorded, moved on to other stations, and okay, cool, I'll go out to that site, and then someone's vandalised a sprinkler and you've got water flowing out everywhere or something. If the other side of it is, it will find if you've got mainline breaks, the same thing. If it experiences a high flow on one valve, it'll move to the next valve. And then if it still experiences high flow, it moves to the next one, does another test. And if it's still experiencing high, it shuts all the valves down but leaves the master valve on. And then it goes, well, why are we still seeing flow? Because obviously all the valves should be closed, which means your main line's blown. So then it will shut your master valve down, shuts the whole system down, and then you would get, at that point, you might get a different alarm, and you can set that up to sort of say, if that happens, I need to know. Yeah, pretty much. Like that's a call out. Like I'm now getting up and dealing with this because I've got water pouring down the road or something like that. So yeah, you can adjust it and set it up differently to how you want. All right, so when we do diagnostics, a lot of the times you guys would find, I guess, coils that don't turn on the field, and controllers can tend to sometimes give ERR station like #2 or open, or like depending on the controller, they'll give different sort of feedback on those controllers. When a solenoid valve doesn't turn on, what's happening there is there's a couple of different things that can happen when it doesn't turn on. If the controller's telling you, it's because it's something electrically is happening, because it can't know what's happening from a water standpoint. So what we tend to do, and I don't know if you guys run multimeters at all.
Got one.
Yep.
Which none of us know how to use.
Yeah, that's all good. This can be done at the controller as well, which is when I used to do diagnostics for all sites, you would, instead of going out to the field and dealing with what's going on, I would know straight away from the controller how to find a fault in a controller. Now, what we have is, so feel free to grab these. I'll show you how we do this. So what we can do, grab another one for you. Just one more. Yep. No worries. You'll see on the dial, down the bottom left in the green area, there's that omega symbol. If we go down to that and to the 200 of that, which is effectively your dial pointing all the way to the bottom. Okay. If we go across the coil, and you'll see this now on mine, and you can test it on the valve yourself, but if we go across the coil, now again, this is AC, it doesn't matter which way we go. Even though these are black and red, it doesn't matter on the valve. And we're getting a number now of 25-ish, 24 and a half. That tells me anywhere from, I would say 18 to 60 in a number, I guess a reading of that sort of description. That's our ohms of resistance that we're seeing. That tells me that the coil's good. I would hope so. It's a brand new coil, but it's a good coil. Now, what would happen if I went like, and this would be, I don't have a broken coil, but we would see, you see that OL, overload, excess, like there's a number, something, depending on the multimeter, how they report it, you get a different report. What that tells me is inside this, that's bridged. Like there's an actual, like it's closed off, like which means that's burnt out and it's all melted together or something's happened inside there. And so we would know straight away that that coil's done. If we see something like, we go across that and we get 7, like real low numbers, what that's telling me is I've actually got a potential crossed like join. So someone's done, you know, when we were talking about earlier where we're twitching wires together in a valve box, there's potentially these wires just resting against, like the two colours, like the different colours are actually touching each other, and so there's an actual potential bridge there. So we're knowing that there's something's going on. The reason I say this is when we go across to a controller, for example on here, let's say someone said it was coming up on the controller, ERR #1, station 1's got a problem on it. I go across with my ohms of resistance test and I get against the C and the 1. This doesn't need to be on because we know that all the wires are still there anyway. So we're doing the exact same test I've just done. So we go across here and I would get, if this was wired up across C and 1, I would get that 24.6 ohms because I'm connected straight to that coil. And so which tells me, okay, the coil's good. So there's another reason why that valve's not coming on. Does that make sense? Yeah. If I went across to here and went across to C and 1 and my multimeter came up as 1 or overload or excessive, that tells me the coil's done. Now, 90% chance that if that did that, and this is how it happens when I've gone out and done diagnostics on the field, I go across C and 1, overload. I know if I knew what the valve was that's out in the field, like it was Hunter valves, the first thing I would do is go straight to my ute and grab some wire joiners and my tools and a spare coil. And I would turn the valve, this off, take my coil out, put a new coil on. Before I do that, I check my coil is good, so I'm not installing a dead coil. Check the coil's good, yep, got numbers connected up. 90% chance away your system goes again. Because coils fail, I'm assuming you've done plenty of faulty coils out there, so yeah. That's the easiest way about you haven't touched wire joiners at that point, you haven't done anything in regards to in the valve boxes itself. You're literally at the controller and that station hasn't been turning on, and you'll know because it's, it's dead or dry out there or whatever. You just go straight up with your multimeter to those across the common and the station that's in question. And normally you can go to another station and say, well, 3's working, what's that giving me? And you go, oh yeah, 35, cool. 2, 35, cool. 1, overload. Okay, 1's got the issue. And you know straight away, 1's got a faulty coil there, and you can go straight out there and fix it up.
Sorry, I missed what you were putting the multimeter on.
Yep, that's cool. So you would take it all the way to the bottom,
So the 200.
where you've got 200 and you're looking for ohms, which is that
ohms,
omega system.
cool.
Yep, all right. So yeah, what I'll do there,
Get one, yeah, you got that?
if you do that on a coil now with your Omega system, you can go across any one of those. There's no electrical current there. We're only testing for resistance. And I think honestly, from a fault finding point of view, it's one of the most easiest. Like, it was actually great for when I was doing call outs, because I'd literally go to someone's backyard and I knew it was going to be that or a Rainbird valve, and you'd go up to it and go overload call valve, and I'd say, oh, $50 for a coil plus my call out fee, and I'm out of there in 15 minutes, and it was great. Like, it was an easy fix. Until it wasn't, and it was always the days that it was raining or something. But yeah, so yeah, exactly, and that's where it becomes a whole, like. And speaking of which, then it becomes a problem if you're only getting, as I said, if you get really, really low numbers, it's telling you that there's a nick in the cable out in the field. That's where you need to probably have cable location diagnostic tools in the ground, where you can connect them to the wires that are in question, and it puts like a tracer voltage down that line, and then you walk around with a wand, and like a cable locator guy's going along and he's trying to find it, and it will tell you the power of the signal, and then all of a sudden you'll get to a point where that signal's worse, and it won't be in a valve box necessarily. It'll be somewhere where you maybe have a tree just snapping the cable a little bit or something like that. So you'll be able to actually find it. So, yeah. So yeah, you'll be able to test across there. No, I'm okay, thank you, mate. All good, thank you.
Have you got notes on this?
I do have I guess how to test. I've actually done a diagnostics like sheet that I've done for City of Playford. And I ended up emailing that to Lisa, and then Lisa just put that out to all of our guys just to have in the glove box of a car. And it's just handy to have, because you might.
Yeah, but then when come summertime, we go, shit, what was that?
Yeah, was it volts or ohms that I was going to or something? That's right. And what numbers are we looking for? Yeah.
Yeah, cool.
And so while we're talking about that, obviously when we're connecting to the controller, this one is powered. So now this one's powered, and this is like, pretend it's on a wall. Using our multimeter, we would go to the volts on the right hand side, which is the wave, and that's telling me it's an alternating current AC.
So the one on the left is if you want to do a battery like that.
100%. That'd be if you wanted to test a car battery, or a 9-volt battery, or a AA or something like that, because it's a DC valve.
Yeah.
Yep, so then obviously, and we know we don't want to be looking at 200 million.
No.
So we would go to that 20.
Yeah.
Yep, because obviously a car's going to give you anywhere from 15 to 8 volt, depending on where it's at in its charge. Right. And so that's the same sort of situation. You would able to use this and go straight across to number 20. And again, when it's DC, now that we're talking DC, in a node or something like that, polarity is different. So you have a positive, like a car, you have a positive and a negative. So you need to make sure that you have your black in the common and your red in the VMA port there. And I normally, to be honest with you, because I don't test, I'm not an electrician, I don't test these things on 240 volt. Yeah. You can, but I don't want to go, I just don't feel comfortable going up to a PowerPoint with these. So you would be able to test 240 coming into controllers and stuff as well. So for this exercise, we're going to be using the VAC, which is that V with the wave. Obviously, we don't need to see 750 in high volt. We want to just see that 200, which is our standard residential style or lower. Now, on the controller, sometimes the other side of things is the controller's dead. It's giving me nothing at the screen. I don't know why, because the PowerPoint's on. or first check the power point's on, but the power point's on and it's all good. What I then do is I go, okay, the power point's on, but am I actually getting power? So I normally have a phone charger or something that's there, and I just test that power point's good to go, because again, these things are 15 bucks each. I question how much they can save me if I was to put that into a light socket. So I prefer to just plug something into the power point and do a test. If that's still giving you 240 volt and you're getting power to the thing, we know the power point's good to go. Now we want to test that we're getting power into the controller. All right, so what we then do is you'll see on all controllers, you've got cables coming out of your controller on here. Okay, and you'll see on your left-hand side you've got 24 VAC, so it's 24 volts AC current, and we're seeing on here. Now that power is coming from the 240 volt and going into a transformer behind here. And the reason that's been locked away is obviously because accessing that is an electrician only situation. However, the ports on the top, however, because they're accessible like they are, is extra low voltage. It's 24 volt. That's what your valves are getting delivered to. So what we want to do there is we've got it set at 24 volts AC current, and we go across, and again, because it's AC, it doesn't matter which polarity. We go across and we're getting volt. So we're seeing, okay, I'm getting 24.8, 24.7 volts. Okay, that tells me the transformer's good. I'm getting power to that. The transformer's delivering the power that should be to that controller. Are the connections okay? Yep, they're okay as well, but I've still got no power. That controller's dead. That means that something's fried in the board. Try a reset, it might flash it, but it's likely that it's either a warranty or it's a new controller, depending on its age. If you go across here and we get 0 or 2 or 3 volts, well, hang on, that's supposed to be, and it's pretty clear because it's telling us 24. Well, we're not getting that. That means that's probably fried. Now, depending on the controllers, you can buy a 24 volt transformer. Most of the time, it's part of the controller. So if the transformer's faulty, then the controller in essence is faulty. So the manufacturer would just give you a whole controller 90% of the time, if that makes sense.
To be honest, we haven't had a lot of issues with power.
Yeah, which means your power's probably clean then, so you're not getting big spikes and voltages coming through. Are you getting issues with down to the valves, lack of volts down to the valves? No, cool. So if you, just to give you a quick test on that as well, if we were to turn a station on, let's say we want to give station 1 a runtime. That's delivering volts down to station 1 now. With using the same volts, I'm going to go across 1 and common. Am I doing this right? I reckon I've just found a faulty controller. Like, legitimately found a faulty controller.
Well, that's one issue we might have. If we set that one out in the field.
Definitely.
That's the older version too, isn't it?
Yep.
Controller.
How's that for a training session? Just found a faulty. I won't sell you this one. Yep, so I'm getting volts to there. But you can see I should have, what I see there, I should actually now, because station 2's on, I should be getting the same. I'm not getting anything. Now that's telling me something's happening.
Station 2's fried.
Well, station 1's not working, station 2's not working, so I'm actually getting no volts on that controller, so that's actually giving me a fault on that controller. Now, if it was giving me a voltage, and we're like, yep, we're happy with that, I'll go, okay, cool, I know the controller's got power, it's doing everything it should be, I'm okay with all of that. And then we go out to the valve box and we would say, well, but why, if I open up those wires coming from the field, and I did, you know, you had green on one and the white on yellow, so I went across to green and white in the valve box, I'm getting 6 volts. But I had 24 here. Why is that? There's multiple things that can be that, but 90% of the time, it's going to be that you've got a nick in the wire. So voltage leak is happening and you're losing voltage. And you'll tend to find that happens when it's wet, because obviously there's moisture there and it's taking that away. It can also be that you have gone too far with the cable as well. So you've got too much voltage drop on the cable. We're using a 1/2 mil cable here for jobs. Commercial standards, I tend to stick with 1 mil because we can go up to about 180 metres with that. And then beyond that we go 1.5, and then we put bigger size commons in where we can go 1/2 kilometre and all this sort of stuff. So, and the reason we do that is because we're going, these 1/2 mil is probably good for about 100 metres. Now, that doesn't work for a football oval. Well, we've got to get all the way around the other side. So to do that and achieve that, we have to put a fatter cable in. So we go to 1 mil, 1.5 mil to be able to get around there. When I've seen jobs that have been, I guess, aggressively priced to win a job, they go, oh, we haven't got voltage, or the solenoid was okay in the first 6 months because it's a brand new solenoid, but 2 years, you know, a year later, that coil's had work now. It needs all that voltage to kind of get going because it's worn in a bit more. Now it doesn't work, and we'll go, well, hang on, you're only getting 12 volts down there when you should get 24. You've got too small a cable. Someone's cut corners on you, and it happens a little bit with the contractor side of things. If they've not had this understanding and they think irrigation cable's cable, it doesn't matter. It does matter. But if there's any of a question in regards to that sort of stuff, obviously give us a call. We'll on the spot help you out and do some tests over the phone. That being said, in that sheet that I'll give you to print off and distribute out, I'll send it to you, goes through all of how to do those tests as well. All right. Does that make sense as far as just doing some quick multimeter diagnostics on stuff? There's not much more from a diagnostics with the multimeter to test for valves. From an electrical standpoint, there's not much more we can really do at a basic 24 volt controller. Do we have volts or not? Yes or no? And what's our ohms like? If our ohms are good, then the coil's okay, so something else is happening. Go back, check your wire joins, cut them off, redo them, make sure they're all good again. Before I do them, twitch them, because you're not going to leave them like that, but just twitch them so you know the copper's touching each other. Get someone to turn the controller on. Okay, now it works. Okay, cool, I know it was a wire join then now, so then I can cut that cable, do a new wire join, test again, we're good to go. All right, cool. So what we've got in our controller, obviously, as Scott was saying, and I was saying at the start, obviously everything tends to want to flow that clockwise direction in a dial controller. Other controllers have different operations, but 90% of the controllers that are out there now are dial. The new Rainbird IVM is still dial, but then they've got, I guess, a series of buttons that still allow you to navigate whilst you're inside that menu. Even the most advanced controllers still have all that now. So the first things you're going to do with a controller is we're going to move across to the right, which is current time and day. So honestly, this is the modern version of that, but you can see that we're doing the same sort of thing. We're going to go across to that, and that just puts us into a menu where we can actually see the year. We would then up that to, it's literally an up and down button, to 2021. We press across on that, and then the first thing that's flashing is and they've showed that in a picture, which has actually got a 1 and a 12. And the reason that is because they've been geared for Australia, whereas traditionally the controllers used to be 12 and 1, and so you'd do that whole January 31st instead of the 1st of January, so we tend to go that way. So I'll leave it as the 1st of January, but you can obviously up and down accordingly here, and then you just move to the next one, and that's now we're dealing with the month as well. We go across. Now we've got AM or PM, as well. So yeah, we've got AM or PM, and we go across and we can start setting our hour, and then we go across again and we can start setting the minutes. And we're not setting, this isn't start times or anything like that. This is purely just the current clock time and what day we're in. So that's just this base point, and that's the first thing that we want to set in a controller, okay? The next thing we go across is our start time. A big problem we see with controllers that we get a phone call from is, I've set the controller up, I've done it fine, but my yard, everything's on all the time and it's watering forever. But I've done it all properly though. Now, I say, how many start times have you got in there? Well, I've got all 4 in there because I've got 4 stations. I was like, no, it's a big misunderstanding, but it's the start times is when do you want that program to turn on? So, for example, 8 o'clock at night. So when we see up here, we see number 1, that's start time 1, not station 1. And so it can be very, very misleading because people will go, okay, well, I want station 1 to come on at 8 o'clock. And then they go across and they see number 2. Oh, station 2, I'll put that on at 8. And they work back and they go, well, station 1 was on for 30 minutes, so I'll set this one for 8:30. What's actually happening there is program A is going to start at 8 o'clock and go through all the stations. And then it'll then look and go, oh, we're also supposed to have started at 8:30. So let's come back and we'll do that again. And all the stations will come on again and it'll go to 3. And so now you've watered 4 times as much in one night. And so then they get a nice heavy water bill. What's going on? So always remember, and this is the same for all controllers, start times are for an individual. So when you see the 1 or the 2, it's for that start time, not for the station accordingly. So what we'll do here is we'll go start time 1, and I would literally just press up here and I'll say, I want that to come on at 1 AM in the morning. Okay, and it's just literally as up or down to when we want that to be. I want to go across to start time 2. I'm going to leave that as off because I don't need it to come on any more than once in a night. Start time 3's off, start time 4's off, we move on, and we're happy with that. The next thing we go is run times, and I guess it's handy that they've got them 2 together because you can, I guess it reminds you that run times aren't start times. Run times are how long you want it to run for, and start times is when you want it to come on. So when we go to run times, again, now we're seeing an hourglass, which is its run time, and the number 1. Now that number 1 is station 1. So we would say, oh, okay, I want that to be on for 5 minutes. And it's just a case of up and down. We can go the other way on here, and we can take it to the back way, and then it flips it so you can sort of come back the other way. And with this controller, it will go from 4 hours. Other controllers, I think, take it from 6 hours and 8 hours, depending on the commercial level of the controller. This is a residential controller, but gets used in commercials as well. So yeah, we'll go put that on at 5 minutes, and you'll notice here, and this is a big part of how it's easier to tell as well. This is an 8-station capacity controller. You will know obviously on the other controllers how many stations you had installed. If you press across, you've got number 2. And if we keep going, you can see I can get to 8, but I can't get to 8 in start times. I can only have 4 start times on this controller. So you'll sort of, and that's where people can get caught, and it will actually help them because they'll go to put start time 5 in, thinking it was station 5, and it's not there, and they go, oh shit, that's right, I needed to go and get rid of all start times 4, 3, 2, and go back again. Does that make sense? So you can put all your run times in for your stations here. So for this situation, I've just put that's to come on, station 1's to come on at 5 for 5 minutes, sorry. Then we go across down to water days. All right, water days is on, and you'll see if we look at water days here, and I'll just go around the table, but see how we've got Monday flashing, and there's water droplets on all of these. If I press minus, See, it puts a no on it, like a cross across it, which means Monday won't come on. But I want Tuesday to come on, and then it will move across. So plus being yes, minus being no. And then I would press, I don't want Wednesday, I do want Thursday, I don't want Friday, I do want Saturday, and I do want Sunday. So you can see how that's it's set up, that's ready to go. And you can just go through and change all that as you see fit. And just literally a plus and minus to whatever suits. When you do that on a Hunter node, I don't know if you've got Hunter nodes out there, it's exactly the same setup as this. Other brands, same process. 90% of the time it's plus is yes, minus is no, and you just, as you press that selection, it'll take you to the next day. If you're wrong with it, just move through and you'll come back. Obviously you've only got 7 to deal with, so you'll just come back again.
How many nodes you got out there you're in stock?
30.
Oh, that's not too bad.
Maybe
Yeah.
a few more, can't really, what do you think? How many you would have to?
Yeah. So does that make sense what I'm saying here as far as the plus and minus on the actual? So if you just wanted to say that's flashing as no, but I wanted to make that yes, you can see now it's got a water droplet on there, so we're good to go. All right. Now effectively, we've set the current time and date. We've set when we want our program to come on, what runtime per station, and what days of the week. That's the schedule. They're the only factors that need to be done for a controller. The last thing you need to do is move that through to the run position. Like all controllers, run doesn't necessarily mean you're going to run it. It's other controllers I think have auto. The LXs I think have them set to auto. The reason Hunter have done that as run is because you can select a manual station and then flick it to run, and it does it as a manual start. But that top always is the auto settings, which means if left now, it's got its clock set, everything's in there, and it will come on when it needs to come on. If you have your controller set to system off, nothing happens. The only time you can override that is if you've got central control, and you'll know if someone's gone and done that because the new central control software will tell you.
Yeah, that's why you can't.
Not yet. No. Yeah. So.
Operated, if you go and turn it back on.
Yeah. Okay. So Rainbird's IQ4 has the ability that you can actually override electrically what the dial's been done. But when you get to site, it'll say conflict in dial, please turn it to this, so then it all matches again. But if you had someone went and did some tests and then accidentally just turned it to off, and you got a notification saying they've left it to off, you can go set to auto, they've mucked it up, and you can electrically override that, which is handy because then you don't have to do the drive out. So that's pretty much it as far as setting the program up on that side of things. Other than that, we want to be setting up, obviously we've got system off now, but if we wanted to turn a station on, we just move it to manual station, and I think they've got, all the controls are pretty well in the same area as far as where we want to be turning them on. We just go to manual station, and you can see station 1's coming up, flashing. With that predefined runtime that we'd already set in there, it just brings that through as the default. But if we wanted to up and down this from a manual standpoint, you know what, I don't need it to be on for, it might be 40 minutes. I don't need it to be on for 40 minutes. I just want to see that it's okay. I'll just give it 2 minutes, and then I'll let it pop down again. Because I've got people walking over. I think 2 minutes is fine. They're not going to get wet by then or what have you. So we see that on as station 1. It's flashing as 5 minutes. All we do there is move that to the run button, the run dial, and you can see that you've got that flashing little sprinkler. You see that little sprinkler symbol flashing there? That just tells me that there's actually operation happening now. Now, that's when I did that multimeter test. I would normally have done that and go, yep, cool, the controller's telling me it's watering. I'm getting no voltage though, I've got a problem. But normally you have your sprinklers pop up and you're good to go and you can move. If you wanted to and you're like at the controller and you're looking out on the field and you can see it happening, cool, no worries, I'm happy with that. I don't need to wait for 5 minutes. I'll just move to the next one. Literally press across, and this has got 0, so we just want to give it some runtime. And it's now going to start watering for 2 minutes. Yep, I'm happy. I've seen that one again. Move across to the next one. On it comes, starts watering again. Oh, I've left it for too long, but because when it's got 0, if you don't give it a runtime, it's going, oh, well, then it's done. So it'll shut down. Obviously, you would normally have runtimes in all your valves, so you wouldn't have an issue with any of that. Solar sync settings. Do you run solar sync? No, cool. Ignore solar sync. I wouldn't worry about it. Hunter's probably watching, but I don't believe in solar sync in that regard. I think it's too convoluted for what it is. And then you've got obviously seasonal adjustment is handy as well. So you've already set a January budget, and you might do this a little bit from IWMS a touch.
I tend to just change the whole program, but there have been times where I've used seasonal adjustment.
Yeah.
But would probably be the thing that complicates that is you've got,
Microclimate areas.
Yeah, you might just too many different things on site to go, I want to increase it all by 20%.
Yeah, that's too much for some areas and not enough for another area. So yeah, correct. So seasonal adjust purely is just a percentage-based adjustment. So if you set everything for 40 minutes or whatever you might have set, and you're happy with your application rates, but hey, we got a heat wave coming in. The next 3 days straight of 44 degrees in a row. That's not enough. I need to put it all up. Instead of going into each station and upping the run times, you can go to your seasonal adjust and literally go, at the moment it's set to 100%, and we can just press up and take that up by a percentage. So we're at 150, so it's going to, if it was at 30 minutes, obviously it's adding another 15 to that, if that makes sense, because it's 50% of an additional. So now we're going to have 45 minutes of runtime. But as Scott said, that's global. So that's great if you know what's happening on site is relative to all of it and you're okay with that. But if you've got a shady area, that's as good all year round. It doesn't really need much more. You go and put 50% more on now, you've got moss growing on your turf and the other areas are okay. So just being mindful of that. The other side of it too is remembering that at a controller level, you set that, it's done. So after the heat wave, come back. Otherwise, you're going to get some water bills. And the other way too. Remember the really, really wet springs we had and whatever. It's like, well, I don't want to go around and turn all my controllers off. I still want to give them a bit, but they don't need to be where they were. So I might go to 70%. So we can go the other way and take it down the other way as well. And I think we can go down to 10% of watering, to the point where if we were watering at 10% of your schedule, I would say you just probably should leave it a few days and then give it another good drink, because you're probably not putting enough on to even do anything. It's just wetting the thatch. So yeah, does that make sense? Yeah. Cool. That's pretty much across all controllers the same thing. Even when you go to central control, you're doing the same setups, schedules and what have you. So yeah, that's pretty much as far as that goes from a controller programming point of view. Is everyone comfortable with our wiring up of the valves and back at the controller? Obviously, we've done that wire up and how to fault find everything there as well. That's good. All right. A couple of things I just wanted to quickly touch on was obviously PVC repairs in the ground for you guys if you're fixing stuff. We see a lot of the time, telescopic coupling slip fixes being used. Great product. They're a fit for a purpose product, but problems we see with a slip fix, and not everyone may know this, but they should not be used in a mainline situation. So on a lateral only, ideally. You still get people put them in a main line because that's the way of fixing something for them as well, and that's fine, but it should ideally be used in a lateral. When I say a lateral, is after the valve, so we're downstream of the valve here, we're going off to sprinklers and that sort of stuff. Reason being is because that's not under as much load and pressure, and there's not as much force happening inside that because there's pressure being escaped. They can handle the pressure. It's just that movement that we don't want to happen coming from the network. When we use a slip fix or a telescopic coupling, these ones here this is the dimension of 25. This is a 25 mm slip fix. That's the dimension of the pipe, and that's the dimension of a coupling or a fitting, if that makes sense. So that's a joiner. You can see that's the same internal diameter, whereas that goes on. Okay, so if you had a break in a pipe, and I'll do this here, but if this was a break in a pipe and we had to fix this piece of pipe here, obviously we want to clean our pipe up and what have you, we would prime the pipe with our pipe cleaner and prime our fittings as well. Using a glue point, we obviously glue that fitting into this side, and then we would glue our coupling in on this side as well. That might have been a T or an elbow already sitting there that we can go into. In this situation, we're fixing a broken bit. So we've cut that out. We put our coupling on here, and we want to slide that fitting back into our pipe, if that makes sense. And effectively, if you were primed and that was in your brake, that's your repair join done. One thing that's critical with a telescopic joiner though is we don't want to see that is your repair. And what I've done there is I've only, see how that was half extended? We really want that all the way out. And so what we do there is if we had this, we would know, you know, in the ground, obviously we can try to sort of test how far we're going to be with our connection. Obviously we're going to come inside to here, you know what I mean? We're going to cut that pipe, then we bring that back, clean all that pipe up with our markings, do our prime and slide that through so we're extended. We want to get that to fully extended as much as possible. The reason being is it acts like a shock absorber otherwise, because if you've extended, the pipe's rigid and it's like normal pipe. Whereas if you're halfway, as pipe pressures are moving and water's happening, what's happening is your pipe's doing this in the ground and you don't know it, and then obviously that's just wearing a rubber seal that's meant to not be always moved. Or you tend to see things like, and I won't be able to do it, I haven't got the force, but that start to bow and then bang, you've split it here or it's failed again. So just if you are using slip fixes, be aware, fully extend and then you're good to go. All right.
So that directional?
No, non-directional. No. So contrary to some people feel that, like, obviously that goes that way. When I've spoken to the manufacturers, they're like, no, providing it's an extended fitting, it's fine. Yeah, they said if you can't extend it, like you know you're hard up and you just can't do it. They said they want to sort of make sure you can kind of pack that to stop it from trying to move, or pack the fittings at the end, so then that's not allowing that T to sort of be bowing out and what have you. But yeah, from a directional standpoint, no. Because I asked the same thing, because we used to get people say, I've been told it's directional and what have you, but they said if it was, we would be putting a flow arrow on them. So, yep. When we do main lines, and I guess and other PVC fittings, these are great. The next step up, and I think actually cheaper, pretty sure they're cheaper, is a compression coupling. I don't know if you guys have used the compression couplings before. They make them in was it cast iron as well in the bigger sizes once you go to 80mm PVC and that sort of stuff, but these are a great unit. These are a Watermark approved product as well that will allow you to fix your main lines, and as you can see there's no flexible movements here, it's just O-ring joins that we're working with here as well. So if we were doing a join in this situation, we would just back this one off a little bit and we would slide our pipe over that, and we do this collar up as tight as we can, and that grabs that pipe. Then we would obviously, and this is where the slip fixes are great because you can obviously move it, but we would then have to fix here. Now in this situation, yeah, great, I can do that, but if that was in the ground, I can't. So what we would then have to do is I'd get my coupling, and because these are an internal barrel, as you can see they go all the way through, there's no sort of stop on them, is I get a piece of pipe that's effectively can go inside that, if that makes sense. So I get it like almost like you would, I guess, treating it like a slip fix a little bit. You get a piece of pipe and we would slide that pipe in, glue that coupling on, and then pull that pipe back into that fitting and then do that compression coupling up.
They don't need to join in the middle there, the pipes?
No, they don't need to touch in the middle. You just need to get them past, you need to have them past that O-ring. You don't want them halfway on the O-ring, you want to get them through the O-ring. Yeah, that's correct.
So you could also then just if you had like a hole for the pipe, you could just cut like a couple of inches out, flex it up, push that on too far and then pull it back.
Yeah, exactly. Yeah, so that's because it's like a slip coupling effectively. Yeah, you're right. If you got enough that you could get in there and do like leverage that up, slide that along the pipe, obviously clean it up, and then bring it back across, do it up. And then that's your brake was effectively in here, if that makes sense. And you just, or you could leave the brake in there if you could get it over it enough. Like if it was just an open crack or something. Yeah, definitely. So that's your main two PVC fixes, obviously, other than just straight up couplings and that sort of stuff. I tend to prefer the compression coupling as far as there's other councils now that have gone down the path of slip fixes are not to be used in any situation, and only these. And honestly, I think it's a little bit, it's extreme.
Cupboard full of slip fixes.
Yeah, that's right. Yeah, and I think there's still a strong place for them. Like I wouldn't go as far as saying that they're not to be used. I think we sell heaps of them, and they're a great product. I guess the key is knowing how to use them properly, not just get them halfway and go, yeah, that's good. Again, as we were talking about before with, reusing bloody wire joiners and whatever else, sometimes you've gone, oh, it's glued, and that's not fully extended. That's already, and you've used a fast set glue or something, you're like, I'm not pulling that apart and throwing that in the bin. I'm going to deal with that. But when I say that, just try and make sure that as you're backfilling and whatever, that you are trying to retain some level of movement as much as possible, because we just don't want. I've gone to sites and you've seen, pipe that might have been on the ground and it's doing that because that's starting to. You're just giving it more distance now, so it's something wants to bow. So yeah. When we see, and I'll probably just go now into probably some sprinkler faults that we see as far as sprinklers not popping up or water spurting out of the sides of them. Obviously I've used the Rainbird 5000 here as an example, but there's all gear drives are pretty much the same as far as how the errors can be. If a sprinkler's not going down, I'm sure you've seen plenty where you've just got to tap them down, or when they turn on you'll see water shooting past during operation through where the seals are. What's happening there is on the actual, this is just your riser stem, there's an actual O-ring inside here, or wiper seals. That sand's got inside there and is actually wearing, it's rubbing every time on that plastic and has scored the plastic, and so that tolerance between the rubber seal now is greater, so water can get by. So what's happening is you're getting water flowing past, bubbling around the sprinkler, a reduction in pressure on what's coming out of your nozzle, so you're getting, I guess, double hit because you're getting puddles here and not enough pressure out on your sprinkler. Depending on the nozzle, the sprinkler you've got, you can replace the wiper seal that's there by pulling them apart. That wiper seal costs more than the sprinkler as a part, because we bring in thousands of these, and maybe 20 of the wiper seals. So it's honestly, if you had a wiper seal issue, I would say, and you're using the same sprinkler, it'd be honestly as simple as leaving that canister in the ground, like so, turning that station on, like taking this out, turning the station on and flush any debris out of there so it's all clean. Make sure you haven't got too much sand around that sprinkler. Getting a whole new sprinkler, but take the canister out of a new one, drop it in, redo it, and you're good to go. Because that costs, this is 19 to 25 depending on the type, versus I think it's 26 for a wiper seal. So it's sad, but the reality is just, yeah.
You want one part for a solenoid.
Correct.
It costs more. So
Diaphragms on a solenoid valve I sell them for $27, but I'll sell a valve for 19. Do you know what I mean? Because, and half the time if someone's really adamant and they'll say, I don't want a valve, I don't even hold the diaphragm. So I'm like, okay, cool, I'll just pull a valve. I literally consume a valve, give them a diaphragm, and I've made more money. But I'm like, you could have had the whole valve for less.
And DC
So
and electric coils, like it's cheaper to buy the DC coil and the And
a valve separately.
valve separately rather than buying a DC solenoid with a DC coil.
Okay.
So
And that's how we sell them now. So if we do a DC system for someone in residential, we'll sell them that AC valve, and then they'll get bags of DC coils at the same time.
But they just their AC valve.
Yep. Yep.
it's probably good for you if you
And the reason being is we're paying an Australian manufacturer that imports the Hunter product to be doing that. And so then I pay that, and then I've obviously got to put a percentage on my product. And so then at the end result is you guys pay more, whereas it takes you guys 10 seconds and you've saved $8 on a valve. So, you know, you're not. And then if you did need to keep spare coils, you've got them. Yeah. Other than that, from a sprinkler not popping down, that's the main reasons. Obviously, when that happens, obviously that tolerance tends to get a little bit iffy, and so then that riser stem could be sitting on an angle, so it doesn't want to come down anymore. Just replace it. What we do see is you've probably seen the stainless steel riser stems that have come out as well. The misconception there is they are not any stronger from a vandalism point of view. They are there for the protection of the wiper seal and the riser stem only. The mechanics inside them and whatever, it's only a thin wrap of stainless. It's purely if you knew you're in heavy sandy situations, stainless is great because it does prolong that plastic from scoring. Obviously the sand doesn't get a chance, and then when it turns on, the idea behind these is they're a tapered seal. So the riser is tapered. So as they turn on, water's meant to come out because it's flushing any dirt that has settled there. And then as it gets to the top, it's fatter at the bottom, and it pushes against that seal, and you'll see, you've probably seen sprinklers turn on and they bubble. That's water flushing away, and then they seal, and then water's good to go. The beauty of like the 5000, for example, is when they then turn down, they flush, but at the same time, they've actually, all their screw ports are actually have water ports through them as well. So you don't get dirt and debris in the top of the gear drives. They're actually, you'll see them out of some of the nozzles and stuff, they're squirting water up in the air because they're actually clearing out the port. So then you go to get a screwdriver in there and you're not flicking debris out. You're actually, the intention is you should be able to get a better grab and actually make some adjustments to them. Beyond that, the only thing you'll get if you've got block sprinklers coming through and what have you, is you'll be able to take your sprinkler out, and obviously most of them are all just open flow case like that. So take all this out, give that a good flush in your system. And it's a good practice if you're on recycled water systems and stuff, or there've been new mainline work. Sometimes you're like, all of a sudden, someone's done work near your jobs and you turn your sprinklers on and your last sprinklers are they're just trickling out. It's normally because shit's finally got through, makes its way to the end of the rotor, and it's sitting in the bottom of here, or it's inside here. In these, obviously turn that on, flush that, and then give this a check. Obviously this has got a check valve in it, but it's also got a screen on it, which is a little filter. Just rinse that out, make sure it's okay, check inside that nothing sort of got through, like, you know, that long stringy duckweed can tend to get in some things as well, especially if you're pumping from ponds and what have you. Put all that back in, put it all back together, set your arcs, and you're good to go. So that can be a simple thing that I see people have gone, sprinkler shit, I'm buying another one. Granted, it's only $22, but that adds up over the years, and then when all you needed to do was just wash that out and your sprinkler was fine to go. So happy to sell them, but there is other maintenance practices there as well. So
if you've got spare ones, change it out, take that one back to the yard, clean it up.
yeah, and the golf guys do that a lot. They're like, I'm not sitting around fixing rotors, I just bring a spare with me that might have already had a maintenance job done on it, and they'll drop a whole, because I mean they're $390 rotors, so they'll drop the whole internal into that and then go back and put a new parts on them and clean them all up, and then that becomes the spare ready for the next fix. So if you're doing any spray jobs, MP rotators, like smaller garden areas, obviously you use a bit more of these spray bodies, obviously whether it's Rainbird or Hunter, or even some of the other stuff like Popes and stuff like that as well, if you happen to have any of that out there. The same process, obviously they're all tapered, so there's a bit more play earlier on, and then once that comes up, that seals against that white O-ring that we've got here. and that stops that coming. When these are bubbling, that's because it's scoring and sand's got in and it's damaged that. You can get, in the Hunter, you can get a replacement seal, not in the Rainbird. I think America they do them, but they don't bring them into Australia. It's a $2.50 part for the sprinkler body. So the time taken to replace that part, and the difference being, and the reason they've said that as well is because if you change that seal, that's fine. You've changed the seal on that sprinkler, but the riser stem's still scratched. So you've only fixed 50% of the problem. And so I just think, we'll just replace the sprinkler. The nozzle might be okay. Still keep the nozzle, because the nozzles, like MP rotators, are $10 a nozzle. That, you know, I mean, that's where your money's at. These spray bodies are, I wouldn't say disposable, but they're, from a repair point of view, they are disposable. You throw them away and put a new one in. So, is there any other questions regarding like maintenance of sprinklers or adjustments of sprinklers that you guys haven't done? All good with that? Yep. Probably the only other thing was articulated risers is another one. Obviously, if you're doing commercial installs, if we're coming out of our solenoid valve, and this is just an example of how we like to set commercial sprinklers versus just burying. Traditionally, we would see from a residential situation, we've got a threaded fitting sitting underneath and we just screw that straight into the ground. That's fixed. I can't adjust that. There's no height variations there other than digging out and moving the pipes or trying to dig them, push them down and what have you. That's stuck there. What we tend to do in a commercial sense is we use what's called an articulated riser, and we use that with a female threaded fitting. So instead of that male fitting sitting upright going straight into the sprinkler, we side mount this in a trench, and what we do is we put these onto that fitting. I don't know if you've done, you would have articulated risers on. So, yep. Yep. So every new install, always as an industry standard, wherever possible, because obviously sometimes we're restricted how deep our trenches can get and what have you, is obviously this is a PVC fitting. We do them in poly. If you were doing a black 19mm system as well, you can put them in, and they're great when it's a new build and you don't have your heights perfectly set yet, because you can always come back and adjust, or if you're top dressing sites over the years, obviously that builds up, so we want to bring our sprinklers up. We put this in, no thread tape at all required on any of this, including going into a sprinkler, no thread tape at all. It's all tapered threads. So that always, if this is your trench bed, so that's sitting on the bottom of your trench, we try and set these at 45 degrees. All right, because that gives us as much this way as we have this way. You know what I mean? We don't want to be setting our sprinkler there, because I'm like, well, how do I get that down? I now have to move that sprinkler away to be able to do any movement. So it's always the case we want to set them to 45 degrees. And the beauty of this now is we can actually, we've got our thread sitting here. And these come in varying heights too. So 150, 200, 300 and 450. So standard is 300. I think this is a 200mm one. And that's just that riser piece there as well. When I say 200mm, it's a 200mm riser that they've used to make that. But that's what you would see in a commercial, in any commercial sprinkler situation, is your articulated riser and your sprinkler sitting on there. The beauty of this is it allows us to adjust that sprinkler this way and this way without moving any of that pipe. That pipe stays there. We can actually set our sprinklers. And obviously when we see sprinklers that are, you know, popping up and they're doing that, well, that's easy. We dig around that sprinkler. We can move that sprinkler back up, get that nice to grade, pack our soil around, put our sod back in, do what we need to do, and we're good to go. A deviation like that on an oval destroys your uniformity of how evenly you're distributing water versus just bringing it back to square. These things are giving out 25 to 26 degrees trajectory. There's science behind it, and then you go and change all that by this, and that happens. It's a soft soil and a mower's gone and pushed that, and it's, you know, things happen. Just being aware. These are handy if you're doing new jobs. To use these as well. And again, if you're stuck, you can obviously change your heights that you need. So, is there any other questions? I've pretty much covered, I think, everything I can. If there's anything else, that you guys want. Obviously, it doesn't have to be today either. You're more than welcome to. I've got my details up there. Scott's got Mudgie's details as well. We are more than happy to. You've come across something that you've never dealt with before, flick me an email. We'll help as well. I'm more than happy to help. There's no invoice attached to the back of it. It's just help. I'm happy to help out. So, anything else?
That's good, mate. Thanks, mate.
Awesome. Thanks very much, guys. Appreciate it. Cool.